Hi. Thank you for coming. We appreciate you guys driving through the rain, through the crazy traffic, through the 10, 20K, whatever this people do when they run. We appreciate you coming out here. Sorry, how many of you have heard of Refresh before today? Cool. How many are new? Cool. So we have a, well, keep your hands up if you're new. So we have a rule, if you're new to Refresh, you have to buy the first drive. Now, if you've never come to Refresh, we usually have beer and soda, things like that. It wasn't possible for this event, but we do have an arrangement with Titanic, which is just down the block. $10 for a basket of wings and a beer. And there's a beer special, so just with your name tag, you should be able to get some stuff. For those of you who are not familiar with Refresh, we are the largest technology organization in the Southeast. We have about 9,000 members. We've been doing this since 2006, every month, without fail, for 9 years. Our average attendance, luckily, thanks to you guys, is around 300 to 350 every month. And we try to bring in great speakers like Max. Last month, we, what did we do last month? Payments. FinTech payments, that's right. So, sorry, there's so many events we forget what we did. And so we're going to be doing another event on May 5th, another FinTech. It's going to be at the New World Center. It's going to be a big shindig. So we'll send out details on that soon. What else? Any other feedback? Oh, our sponsors. So this is in partnership with the LaunchPad, so we want to thank them for helping us out and getting the space and helping us, throw this event. The Simpkins Foundation for their generous grants, and the City FinTech Meetup Group for allowing us to partner with them on their events. And of course, that. Okay, so I'm going to go ahead and introduce Dr. Green, who is the Vice Provost of the University of Miami. He's going to give a couple words about UM and what we do.
Welcome all of you to our campus and to the Newman Alumni Center, and to say how much we enjoy the partnership between the LaunchPad and Refresh. Peter's worked in the LaunchPad almost since it started, and it still helps us out. And as you know, the LaunchPad is the on-campus entrepreneurship resource for students and alumni of the University of Miami, and the more collaborations we have in the city, the better. So we're thrilled to have all of you from Refresh here, and undergraduates, graduate students, alumni of UM. We're glad to have you here too, even though it's right before exams. I have to say that I got a little confused with Peter, because in his world you drink a first draft, but in my world as a professor, people usually write a first draft. So the high-tech world and the classroom world are not necessarily the same thing. Let me just say one other word about what this kind of meeting represents. We believe at the university, and we certainly believe in the LaunchPad, that the only unlimited natural resource that we have on this planet is human imagination. We may run out of oil, but God willing, we're never going to run out of ideas. And the future of our species, and the future of our planet, and the future of our city, and the future of our homes, and the future of our families, in substantial degree depends on our capacity to innovate and to turn innovations into real enterprises that generate value, that improve the quality of human life. So innovation that becomes an enterprise that improves the quality of human life is what entrepreneurship is about. And it is the one way in which we get better. Working with Refresh expands that possibility for us. But what's represented here in this room are people who already at some level are committed to the idea of innovating, of thinking of new things, of meeting new human needs. And I frankly can't think of anything more important than that. I can't think of an activity that's more important for human beings to engage in than this. So welcome to UM. We're delighted to have you here. Thanks again to Refresh for co-sponsoring with us. And to kick us off tonight, I'm going to introduce our speaker, I want to introduce a program manager at the LaunchPad, a UM alum, a double alum, an alum squared, Adrian Alvarez. It's an alum cube.
Yeah. It's always fun following Bill. He always gives great speeches, and it's always nice to hear. So I actually wrote down what my remarks are. So welcome everyone to UM. I'm Adrian Alvarez. I'm the program manager for the LaunchPad. And tonight I'm here to introduce you to our keynote speaker, Max Henderson, the head of Google, the head of Americas for Google Cloud Platform. But long before he got that awesome title, he was just my friend Max from Key Biscayne. The only German Cuban kid I knew. Max's mom and mine have been friends for years, and were actually pregnant with us at the same time. I remember going over their apartment from an early age and was always having an awesome time. As we grew up, we didn't see each other as often, but despite that and his matriculation to my high school's biggest rival, Columbus is still better, dude. We've always been able to pick up right where we left off. Max is one of the most brilliant people I've ever encountered. He's a programmer, business person, an entrepreneur, and creative all rolled into one. And evidently Google found out about all that, making him the head of their cloud platform before even turning 30 years old. So to conclude, I'll read the bio he actually sent us, and let me get started. Max Henderson is the head of Americas for Google Cloud Platform, where he is responsible for all aspects of Google Cloud strategy and go-to-market. Prior to this role, he spent almost 3 years as global head of account management and data science for Google Cloud, leading worldwide customer success, technical advisory, implementation, and business analytics. He has over 10 years of experience in the computer software, hardware, and pharma industries, including roles in software development, strategy, financial engineering, and sales. An entrepreneur at heart, he has founded and held an advisory role at several startups. Max is a graduate of Cornell University, where he earned his degree in applied economics with a focus on linear optimization system dynamics. Everybody, Max Henderson.
Wow. If this whole cloud thing doesn't work out, I could just become a writer of biographies. It's really amazing to me. I just love starting tech talks with a awesome. So thank you guys, Adrian. Amazing. Oh no! Already spilling things back here. So. My name is Max Henderson. You already got the best introduction you're going to get. But I spent the last 2 years running technical implementation for Google Cloud. That means sitting down with our largest customers, helping them deploy their applications, scale, and meet their strategic objectives. And about a year ago, I got tapped to run the Google Cloud Americas business. So that's responsibility for customers, technical implementation, partner relationships, and strategy. And so just so I get a sense of who I have in the crowd, how many of you know what the cloud is? Awesome. Some people are being honest, not raising their hands. How many of you are developers who use infrastructure as a service offering or something like that? Okay, so about half the group. How many of you use AWS? Those people raise their hands. Put your hand up now. What about Microsoft? Microsoft? What about Google Cloud? Oh, what kind of people? Okay, awesome. So I'll get to you guys. I've got a talk dealing with a crowd that is half technical and half strategy. I'm going to try to cover all the topics, from what is cloud, why you shouldn't care, to what is Google doing for developers, and what are the features that are really going to differentiate things. And then if the demo gods will be with me, I'll give you a demonstration of one of our big data tools that I think is really, really exciting. So I'll start just by showing you, if I can get this to work. There we go. Okay, we're off to the races. So Google Cloud has a vast array of services. I won't go into each one of them. I could talk an hour or longer about any of them. App Engine is our platform as a service offering, Compute Engine is our infrastructure as a service offering, and BigQuery is one of our key big data tools. If any of you want to talk to me afterwards about any of these, I'm happy to do it. But for now, suffice to say, we've got a vast array of tools that cover every kind of use case you could possibly want to do on the cloud. And depending on your situation, you could use a variety of different ones. So again, going back to what is the cloud as a foundational element. So how many people think they use the cloud every day? Pretty much everybody. So can somebody volunteer to give me what they think their definition of the cloud is? A developer, somebody, anybody brave? Nobody. Wow. Yes, sir.
Processing power taken off-site instead of
Processing power taken off-site. I think that's a pretty good definition. So at its fundamental level, the cloud is a series of computers, not unlike a computer under your desk, that lives in a place you don't have to see and don't have to care where it is. Fundamentally connected to the internet, that can scale up and scale down, depending on how much compute you need. Sometimes you only need to run a small job, you only need one machine. Sometimes you need to run massive jobs, like you need to sequence a genome. Before, that was a relatively impossible thing to do. Either you'd spend 2 years building your own data center, fill that thing with machines in order to sequence a human genome, or there was no way to solve those problems. The cloud removes the infrastructure complexity from solving those kind of problems by giving you access to what, from your perspective, is an unlimited amount of compute power. Now, we use it all the time. iCloud, a storage service powered and saving computers that you can't see somewhere in the middle of America. But fundamentally, up to today, for those of you who are still getting your feet wet with the cloud is a bunch of computers in a place that you can't see connected to the internet that you can program against as if they were under your desk. But from our perspective, cloud is really only in its infancy right now. Today, the cloud doesn't operate all too much differently than a computer under your desk. You buy it the same way you buy a computer under your desk. You deploy it the same way you deploy a computer under your desk. But we think that this is going to change pretty quickly. And I'll talk through specifically. So has anybody heard of the Datastore record before? Ever? Okay, I'm not expecting that you would. It's a relatively mundane industry benchmark. Basically, it's a big data problem. Take a terabyte of numbers and put them in order as fast as you possibly can to test to see how fast a distributed set of computers can solve a relatively simple problem. Okay? So we happen to hold the world record for doing this. That's neither here nor there. And the previous record holder 10 years ago was Yahoo. So Yahoo did this with an on-premise deployment. They had 12,000 machines, and it took them 1 minute and 2 seconds to do it. We, 5 years later, did it with only 1,000 machines and in 53 seconds. So what does that mean? Okay, well, let's go item by item. So in 5 years, cores got about 10 times faster than they did. So we did it with about 10x less machines than Yahoo did with 5 years ago. Kind of interesting. Time to solve. They did it in 62 seconds, we did it in 53. Okay, also 15% improvement, pretty interesting. But the next line item is cost. So deploying a data center like that, getting 12,000 machines, pouring concrete, putting them in, setting up power, connecting them to the internet, provisioning them, on average, probably costs about $6 million to build something like that. Assuming you already have the data center, you're just buying the machines. How much does that cost on cloud? Well, a year and a half ago, when we beat the record, it was $9, right? So, but, oh wait, there's more. Last year, we dropped price by 53%. So now it's only $4. And if you run that machine for the entire month and you don't just use it for the 53 seconds that you're doing the job, you get another 35% discount. So now it's $2.90. Right? So, okay, you did it in 15% shorter time. But the cost complexity difference between the old model and the new model is 99.99999%. And that's the difference between the old model and the cloud model. Now, where we think things are going is not just the cost complexity, but also the time and space complexity, right? So you've got, it takes, if you already have a data center, and all you're doing is putting machines in it, you might get lucky to buy those machines, provision them, set them up in a month, if you're lucky. If you have to build a data center, it could take you 2 years, it could take you longer than that. The average time to spin up a machine on Google Cloud or Amazon or any of those other services is somewhere between 45 seconds and a minute and 30 seconds. So again, a complexity reduction of 99.99999%. And that is the real value of the cloud. It's not about having computers that you can't see. It's fundamentally changing the complexity model for developing software. And we think it's really just beginning. Because the reality is that once you have the machine running, you still have to set it up. You still have to, as a developer, you still have to keep it running. You still have to write the software against it. You have to make sure that that software runs. And so this is, whether it's your IT budget, whether it's your developers, about 70% of your time is spent just making the stuff work. Just making the infrastructure run, making sure it doesn't break, making sure that the bugs that crash your app go away, and only about 25% or so of your time is spent making sure that or actually writing new software, writing the app, delivering new features, scaling up. So we think that the next phase of cloud isn't just going to be about making sure that the hardware works. It's about making sure that fundamentally you can write software faster, you can write it easier, you can spend more time just writing the code instead of having to worry about fixing it. And what does that, concretely that means delivering you monitoring tools out of the box. So it means being able to see what your application is doing without having to write all that stuff yourself. Performance tuning out of the box, telling you what parts of your application are running fast and which ones aren't. Making sure your application is reliable and can scale to whatever level you need to by delivering services that you can use out of the box. Like, why write your own database? Google stores a copy of the entire internet in order to run its search index. That database would probably do pretty well. It might be overkill for some of the smaller solutions, but it should do pretty well for people operating with a similar type of engineering problem at that kind of scale. And so the idea is to get you to focus on what's important, because, like Bill said, ideas, imagination, getting those things to market, solving not time to answer, time to execution, time to launch, that's really the differentiator. That's really what makes the difference. That's the 10x thinking, instead of just 15% cheaper, 10% faster. So what we ultimately want to do, where we think cloud is going generally, is changing what is possible, both in terms of business model and in terms of speed to market, and not just where the compute is happening. Where the compute is happening is not really all that interesting. So, and if anybody has a question, feel free to raise your hand. Stop me at any time. This isn't meant to be talking at you. So, how many people here use Google Search? Well, everyone, right? We all use Google Search. What about Gmail? Okay, also almost everyone. What about YouTube? Okay, all right. So all you people use Google Cloud a lot. So the way that Google wants to be different in the space, or is different in the space, is 3 different ways. One is, and I'll talk about this in a second, Google has unmatched hardware scale. It is truly, I mean, you hear people say things like hyperscale, like this sets the standard for hyperscale. It's crazy. The second is cost flexibility. So I mentioned before, going back to that TerraSort that I was describing before, the ability to be able to do a job like that, sort something, sequence a human genome, scale up to meet demand on New Year's Eve or on Black Friday. Those are business models that just weren't possible before when we had a physical data center. And we want to put forth the cost flexibility to let you do that. I'll talk about exactly what that looks like in a second. And the last is Google innovation. This is kind of the cool part, the features that I think really set Google apart. Some are around big data. Google has to know its customers, and it has to know what works about its search and what doesn't. It has some amazing tools. I'll give you a demo on one that you can leverage for your own business. And then nearline storage, which is a service we just launched, and containers, for those of you who know what containers are. So for the last 15 years, Google has made incredible investments in infrastructure. Google is a top 5 server manufacturer, and it builds only for its own consumption. It doesn't sell any servers, it's just putting servers in its own data center. So we have the largest network in the world. So, and just to give you a sense of what that means, we own our own private fiber across every ocean. We have 100 peering points in over 50 countries. The only network in the world that is larger is the public internet. There is no other network that is larger. All of our data centers are custom built. Nothing comes out of all the racks, all the switches, all the power, all the cooling, everything is custom designed. There's nothing in there. Some of it is contract manufactured, but it's all of our own stuff, which has implications not just for efficiency, but also for security. I'll talk about that in a second. And the last thing is, we're almost carbon neutral. So for those of you who care about that, I happen to personally care a lot about that. We are 50% more efficient than the average data center in power and cooling, and we buy carbon offsets for almost everything else. So basically, fundamentally, the idea of Google Cloud is let you run on the same infrastructure that runs Google, right? When you use a database out of the box, you're using the same databases that we use internally to run Gmail, to run search. When you store something, you're storing on the same distributed file system that YouTube stores on. When you use an edge cache, for those of you who know what an edge cache is, you're using the same caching network that we use for YouTube, right? So we're delivering video through the same service that you use when you consume videos on YouTube. And it's not just about, so this is one of my favorite ones to talk about, it's not just about hardware, right? Security. Everybody who did not hear about what happened in healthcare just a couple months ago, right? Everyone heard about that. As a matter of fact, Google was impacted. So I had to go and sign up for a 2-year identity protection service because my healthcare company leaked all of my records. So, how many people know what Heartbleed is? Did everybody hear about this? Everyone knows about this? All right, for those of you who don't know what Heartbleed is probably one of the biggest security vulnerabilities on the internet in the last decade. Basically what it is when you connect to a server securely, so you can buy something online, like you go to Amazon.com, there is through a series of manipulations, essentially, a hacker can force what's supposed to be obfuscated or protected data into plain text. So essentially, like, your passwords might have been able to be read in transit by a hacker who understood how to manipulate this limitation, right? So that means that no connection on the internet for the last 10 years can be guaranteed to be secure. Big deal. So in that specific situation, so not only does Google own, like I said before, we have all of our own IP, right? We build our own machines, we build our own data centers, we run all our own software. So a security vulnerability in a regular piece of software wouldn't affect Google because we've written it all ourselves. But in this specific situation where we were very much impacted, we have 450, so sometimes people say to me like, oh, I don't know if I can go to the cloud because I'm not sure it's secure, right? Well, Google has 450 security PhDs on staff. We get denial of service attack once an hour. Right? So like, this is our day-to-day. This is what we deal with all the time. And so not only did we happen to discover this vulnerability, but we patched our entire infrastructure before we even announced it publicly. And what's more, we have what I consider, sometimes technology gets so incredible to me that it becomes like magic and I just can't figure out how it works. One of those things is a service we have called live migration, which can actually take a workload that is running on a machine and copy it so quickly that you don't have to turn it off, and you can move it off the machine so that you can take that machine then and update it. So we were able to, in that fashion, we were able to take all of our customers, our own internal customers, and our cloud customers, migrate them off machines, update those machines so that there's no more vulnerability on them, patch them, and then move the workload back without stopping any of the workloads. Right? And so like when people say, oh, well, I can't go to the cloud because I'm afraid it's not secure enough, to me, I think in 5 years people are going to be saying like, man, I got to get on the cloud right now because like this is really not secure, the stuff that I have running on-prem. Right? Physical security is not the problem anymore. It's this logical software security that's really going to get to us. So that's the infrastructure piece. But the second piece is, all right, all that infrastructure is great, but you have to be the cost leader. You have to be able to deliver infrastructure both at a price point and a price model that people can consume to build new things that are going to change the world. And so we fundamentally want to go back to the original promise of cloud economics, which is use only what you want, pay only for what you use. And specifically for those people who program against the cloud on a daily basis, this means we don't do reserved instances at all, no such thing. The only type we have is on demand. And so you don't make any upfront commitments, and you use it, you pay for only as long as you use it. So if you use it less than an hour, you don't get charged, you only get charged for the time you use it. And if we drop prices, you gain access to that right away. If we introduce a new model or a new chipset or a new configuration, you can access it right away. But more importantly, if you run that machine for the full month, you get the same discount you would otherwise get if you were running a reserved instance. So basically, you don't have to commit to running a reserved instance for a year. Every month, you decide how much you want to use that machine, and we charge you based on how much you fully utilize it. Right? And that kind of flexibility means that if you, say you need to sequence a human genome. Sequencing a human genome takes about 100,000 to 150,000 compute hours. Right? So that's one computer for 100,000 hours, or 100,000 computers for 1 hour, or 200,000 computers for 30 minutes, or 600,000 computers for 10 minutes. Right? And so what this lets you do is imagine a world in which you walk into a doctor's office, take a pinprick, take that pinprick, put it in a machine, send that data to the cloud, and get a fully sequenced genome back to do truly personal healthcare. Right? There's no business model where you actually have a physical machine, whether it's in your own data center or anywhere else, where you'd be able to achieve the level of utilization that you need to in order to be able to make that financially possible. And so this is one of our core tenets. We believe that this kind of flexibility is key to delivering what's next. And then, how many people know what Moore's Law is? Moore's Law basically says that every 18 months, compute power gets twice as powerful. Said differently, every 18 months, the cost of the same amount of compute power drops by 50%. And so in the last 18 months, we dropped the prices on compute engine by 50%. We dropped the prices on cloud storage by 68%. We dropped the prices on BigQuery, one of our big data analysis tools, by 85%. And it's not to show off, it's to say that we think passing through the economies of scale and making compute a commodity is the healthy thing for the market. It's important for people to be able to consume compute at cheapest prices. We are, on every vector, the cheapest vendor today, and we plan on being the cheapest vector, or the cheapest vendor forever. And now comes the fun part, my favorite. Google innovation. So Google's got a ton of really, really interesting internal tools, particularly in the big data space. So, I don't know if the people here Hadoop a lot these days, especially in the development community. A lot of people aren't aware that Google invented Hadoop 10 years ago. Internally, it's called Mapreduce. It's basically a tool for analyzing large data sets in a distributed fashion. Instead of having one machine working on it, you can take a series of computers and split the job up across 10 or 20 or 50 computers. So say you're trying to count 1 million numbers, or 10 million, or 100 million numbers. You could either get one machine to just count 1, plus 2, plus 3, plus 4, plus 5, or you could set up 1 million machines, give each of them 10 numbers, and then add them all up sequentially. And in doing that, you massively parallelize the job, and you cut it down by a factor of 1 million. So the first framework to do that was developed at Google 10 years ago. One of the key storage services that usually goes along with that is called Apache HBase. It's a NoSQL database, also invented at Google 10 years ago. It's called Bigtable. And then Google Dremel, which is the tool we exposed as BigQuery, also became an open source package called Apache Drill. So we have a lot of pedigree in this space. And what we think is, like I said before, the person who knows their customer best in the future is the person who's going to win. Being able to present the right ad, or the right video, or the right piece of content, regardless of what it is, or being able to find the abuse, the hacker, amongst the 100 million users that access your site every day, is going to differentiate the winners from the losers. And so what we do internally and what we want to do externally is deliver fully managed, no operations required services, all the way from collecting your data to ingesting it, and then being able to analyze it where it is. If you need to orchestrate it, if you need to take it and combine it with another data set, reduce it, we have tools for that too. And we can do it not just in batch format, but in streaming, so you can get your data and analyze it in real time. And I'll give you, I'm going to do a demo on BigQuery because I think it's super fun. But here's another really interesting one. So sometimes when you get to a certain level of scale, you can do things that just wouldn't be possible otherwise. And so this is a service we just launched. It's called Nearline Storage. Basically, it's archive storage. So think of, you take your data, you put it on a tape, you send that tape You put that tape in a box, you send that box to a warehouse, you put it somewhere, just in case like the IRS wants to see it in 7 years or something like that, right? But Google actually has so much disk. We have exabytes and exabytes and exabytes of disk that we have space on those disks. Those disks are fully utilized. People are already reading and writing them such that they can't read and write anymore on them, but they've got empty space on them. And so we have petabytes and petabytes and petabytes, massive amounts of just empty storage space. And so we thought, what can we do with this that might change the way that people use storage? And so what we decided to do was create a backup storage offering where you could put all of your data, every single piece of data that you collect, and store it at a cheap backup price. And that makes it interesting to people. Oh, okay, cool. I can store my backup data by Google. But because this stuff is on disks, we can read it anytime. And so, as a matter, with this service, there's no such thing as backup anymore. There's no such thing as archive anymore. Every single piece of data you've ever written is hot. You can read it anytime. So if you make a copy of your database every day for backup purposes, at 1 cent a gig, you don't have to delete it. And 10 years from now, if you ever want to do an analysis on something that you couldn't even have thought of, you can read that data instantly, in 1 second. Right? And so, again, the idea is what kind of new business models can we create by leveraging the scale that we have? In this case, think about collecting access logs. Think about collecting sensor data. Right? Like you could just start collecting sensor data and never stop and figure out what you're going to use that data for later without having to delete it because there's not enough space for it or it's too expensive to store it. And that's the kind of world that we ultimately want to create. And then for those of you who aren't super techies, bear with me on this one. It's one of the things I'm more excited about, but it's kind of esoteric. How many people know about Docker? How many people use Docker? So container-based computing is kind of a revolution in the computing world these days. Basically, what container-based computing is rather than thinking of a computer as the smallest item of compute, I've got 1 computer, I've got 2 computers, I've got 10 computers, thinking about logical compute jobs, a compute job, as the smallest container of compute. So I create a service, a small microservice, that does just one thing. It just takes files and it renders them and it returns them to me. And my entire landscape of compute infrastructure is all just a composite of those microservices. And it is completely revolutionizing the way that people think about computing. For developers, it's super easy to plan, and compose these microservices. For ops and IT, if one of the services becomes diseased, or one of the machines in that service becomes diseased, you just kill it and you start another one. And so deploying more of them is just copy-paste. Whereas with physical machines, you have as many as you have. And either they're being fully used or they're not being fully used. They're also super portable. This creates a world in which you can take, because they run on an abstracted compute layer, you can run them on one cloud and you can take them down and run them on another cloud. And it paves the way for better efficiency because, like I said, because these services are so small, they can be packed better. So you can fill a whole computer with a variety of these services rather than just having a machine that does a variety of different things and sometimes it's utilized and sometimes it's not. Well, so a lot of people don't know this, but Google has only ever run on containers. It's the only thing that we've ever done. It's the only way to manage Google scale compute. So Gmail, search, maps, all those things are built entirely on containers. And we launch billions of them a week. So I think at last count it was 4 billion, 5 billion compute containers a week. So we have a little bit of experience doing this. And we built a couple services around this. One is we worked with the open source community to build a service called Kubernetes, which is basically an open source container orchestration framework. For those of you for whom that sounds only like buzzwords, I'm sorry. But it's based on Google's internal experience with containers. And we have a fully managed version of it too, as part of Google Cloud. So if you don't want to have to run that orchestration service yourself and you just want to be able to spin up containers, you give us the image, you click a button, you tell us what you want the topology to look like, and we spin it up. We manage its health, we kill diseased ones, and we make sure the cluster runs. So those are the three tenets of what Google Cloud is really trying to do. The first is deliver fundamentally differentiated, unmatched scale and compute. The second is do it at a price point that isn't just the cheapest thing out there, but is fundamentally enabling new ways of consuming computers. And the third is transform the way that you run your business or the way that you program by giving you tools, either internal databases, internal services that we have, or big data tools to analyze the massive amounts of data you collect, or take the economies of scale that we have and turn that into new services like nearline storage that honestly you can't do unless you operate at scale like that. So I'll do a quick demo of BigQuery, big data analysis tool, because I love to do it. So let me go to cloud.google.com. So I'll show you how easy this is. I can't see my mouse, so I make doing this demo very hard.
If you look back at this,
Can you see it? Oh, nice. All right, cool. All right, just like this. I get extra points for doing it this way. Okay, so I walk into my console, and I pick a project, and I go with BigQuery. So as I said, BigQuery is our Mapreduce as a service tool. Basically, it is really good at analyzing large data sets in a parallel way so that you can get answers back faster, 10 times, 100, 1,000 times, a million times faster. So the data set I have here is actually really cool. I assume everyone has heard of Wikipedia. This data set is 36 gigabytes, 320 million rows of data. It's a log. Every time somebody changes an entry on Wikipedia, it stores a log. We have the entire record of every change that's ever been made to Wikipedia in this data set. And when an editor goes in and finds vandalism, they can add a flag to that record that they changed to say, this is vandalism. And so what I'm going to do quickly is I'm going to run a query against this data set and say, show me the top 10 in all of the history of Wikipedia. Show me the top 10 most vandalized pages. Go to compose query. I'm going to copy and paste my query from might have to pull it up. There it is. It's nothing fancy. So basically what this query is doing is it's taking this table and it's just saying, find records that contain vandalism, group them by the title of the record, and give me the top 10. That's basically it. So that took 0.7 seconds. And now this is cheating a little bit, I'm going to be honest with you. This query happened to be cached, which means that there was a copy of a pre-finished version stored, which we automatically do for you. I've done this demo a lot of times. Sometimes it takes up to 2 seconds to finish. So what are the top, the entries in a row is awesome. They change from time to time. So the top one is apparently George W. Bush, which is amazing. Most vandalized Wikipedia record in all of history. But some other ones on here are RuneScape, which I have no idea what that is. But I see Led Zeppelin on here, Adolf Hitler, Scientology, Star Wars. So that's pretty cool. It's not particularly useful for anything, except for a good joke. But this is the point for folks here who are reading between the lines is, this is a record of every change ever made to Wikipedia, right? That you can not just search, but count and total the entries across every single row in 2 seconds, 3 seconds. So that's kind of the power of the tools that we have. And think about what you would use this for in your business, right? Even if you don't have a data set as big as every change ever made to Wikipedia. So anyway, that is the end of my pre-prepared talk, but I'm happy to open it up to questions.
Anybody have any questions? All right, so let's go this way. We're going to do, how much time do we have?
Oh, there's one more thing that I should say. I have to plug, now that I'm no longer just doing technical implementation, I have to at least plug the free trial, right?
Yeah, of course.
So there's for those of you who actually want to try it, there is a $300 60-day free trial. Go on, you put in your email address and a credit card, just to validate that you're not a bot or some other abusive person from some part of the world we don't even know about. And we give you $300 for 60 days free. Once the 30 days are up, or the 60 days are up, unless you convert to a paid account, you don't charge your card. So there's literally no risk. That's a thing we got a lot of complaints about in AWS actually. So we don't start charging you. Please feel free to try it. Thank you guys so much for having me here. As a Miami native, this is particularly particular pleasure for me. So thank you.
About 30 minutes, so probably enough for like 10 questions or something like that. For the non-techies who just saw that demo, I mean, it's 360 million records. The part that really blew my mind is that you grouped by title, which is like a variable. I mean, that would take forever.
Hi, thanks for the talk. With Amazon and DynamoDB, they do have a hard limit of 400 kilobytes per row. So I was wondering if maybe you could speak to that a little bit on some of the options available with Google.
Sure. So at the moment, we have a variety of NoSQL databases in development, but the one that we've had around for the longest period of time is called Datastore. It's a little bit different than DynamoDB because it's not a flat key value store. It has an entity structure. And it does also have an entity size limit, but it's a megabyte. So it's substantially bigger than Dynamo. It's different technology with different pros and cons, but Snapchat uses Datastore, and they do about, I think like 1 trillion transactions or something like that a day. So, I mean, it's pretty large scale. We can definitely talk about it afterwards. Happy to talk about it afterwards. Don't want to put some people to sleep with entity size limits.
Very cool talk. So thanks a lot. I had a question on containers, and it seemed very similar to service-oriented architectures of 10 years ago, but like version 2, like service.
Yeah.
They knew, what service-oriented architectures were trying to solve, like really solving. Is that an accurate statement, more or less?
I would say more or less. There are some other promises of containers that are a little bit different than service-oriented architecture. I'd say the container model is more a way of achieving, is a different way of achieving a service-oriented architecture rather than a fundamentally different model. The changing sort of the atomic unit of compute and going to a container-based model allows for, like I said before, better bit packing, but ultimately also, because you're running at a layer of abstraction, allows you to move from one service to the other. So the idea is not just that you have a sort of monolithic service, but that those services are actually portable. And since they're composed of small compute containers, you can spin up much faster, you can spin down much faster, and the operation is copy paste. Right? It's just give me another one of those things, rather than sort of the more monolithic SOA architecture pattern.
Great talk, thank you. Can you perhaps share with us the strategy that Google has on changing the mindset that cloud is insecure or unsafe?
Yeah, so I'd be lying if I said we have a really strong strategy. Honestly, the concerns are more emotional than they are rational, and so it's harder to change an emotional position than a rational one. If I'm honest, I think that in the next 3 to 5 years, there's going to be a security 9/11. It would be like every single, like the IRS has been hacked, everybody's tax returns for the last 10 years are public or something like that, right? And I think when that happens, people are really going to have to take a long, hard look at software that they've been running legacy for 10 years and decide, how do I deal with this, right? There are companies out there who do nothing except just traverse massive code bases, monolithic code bases that companies have to figure out what open source software they're using, right? There are other companies that do that to check for security vulnerabilities. But at the end of the day, like, that legacy stuff that people have sitting around is just a ticking time bomb in my mind. And I think changing that emotional position is going to be, oh my God, I can't keep, like, there's so much evidence, things breaking in the legacy model, I gotta move, right? The same way that today I hear a lot of people come to me and say, like, big data, I need like a big data strategy, right? It's the same thing. I think once security becomes a hot topic, people are going to, it's already starting to become a hot topic, people are going to start to say, I need to do something about this. And they're going to find that oftentimes it's going to mean not just a move to cloud, but it's going to mean a fundamental rewrite of legacy software that's been sitting around for 10 years or more that just works and people don't want to have to do.
Hi. First of all, welcome back to Miami.
Thank you.
Great to have you here. What is your take on what some people call desktops as a service or cloud workspaces running workloads in the Google Cloud?
It's an interesting question. So I worked at Sun on the Sunray before I was at Google. So like moving from client compute to most of your compute sitting in a data center somewhere back and forth, right? It seems like you go through phases. First, you've got a regular desktop, then Sun tries something. For those of you who don't know what a Sunray is, it's basically like a computer monitor that's hooked up with a cable to a server somewhere. And everything that usually happens on your desktop is happening in the server. And so the question is like, we've got a new model now of sort of desktops as a service running in the cloud. Amazon has a service offering. We don't have one yet. I think especially for some particular businesses where there's a lot of data being manipulated, and there's a lot of value in having that data in one place, I think that model is going to be really successful. I think it's going to ultimately be a lot more expensive. That's the reason the Sunray lost, because commodity hardware sitting on your lap is still the cheapest per compute power that you get. But rendering in media is a really interesting example of this. So when you do media rendering, you oftentimes have to deal with massive files that are 20 layers deep. So you've got the animated Shrek in the front, and then you've got his clothes, and then you've got the lighting, and then you've got the background, and then you've got the other renders. And so it takes a massive amount of compute power to flatten this, and then you have to do that 20 to 30 frames per second for 90 minutes. It takes forever. And that creates massive files. Having to move those files from a desktop to a server to render them and move them back, that takes a lot of time, a lot of money. So I think in those industries, that is going to be a winning model. I'm already seeing a lot of people moving to a model like that. For all the other ones, especially where cost is a big factor, cost of the actual compute hour, I think it's yet to be seen. I think there's a chance that it could go the way of the Sunray. Right? The fact that the iPhone has become so successful, and there's so much processing power in your pocket, and that this doesn't just send everything to some server to process and come back, is sort of a strike against the virtual desktop and the cloud model. But not sure.
First of all, thanks for coming out. I really appreciate it. I found this talk interesting because of the distinction between cloud computing and, of course, cloud storage. With cloud computing, as a gamer myself, I think a lot of us sometimes feel frustrations with our rigs not being fast enough, powerful enough to run some of the top-end applications or games that we might be running. So in that sense, I find cloud computing really interesting for me on a personal perspective. But in regards to cloud storage, one of the questions that I have that I kind of wrote down here, there are, like, for example, other services an online cloud storage service that are focused more on user privacy and data security. And what they're doing is they're encrypting the files, our files, with cryptography and state-of-the-art algorithms before they're actually uploaded to the servers. And because the password is never actually sent to the server where this data is being stored, the place where it's being stored doesn't actually have access to the content of the data. So they're not able to analyze the data themselves to perhaps marketing and different things like that. So this means that all those files stay private and secure even when they are in the cloud, which guarantees maximum security for the end user. And I was wondering if Google has those kinds of options, or if that's something that you guys are considering working on in the future as far as maintaining the control more so with the user on an encryption level.
Sure. So first of all, I think there's a key distinction we have to make, right? So there's encrypting the data for non-Google. So if you're storing files on Google, there's encrypting the data for everyone that isn't you and I, and there's encrypting the data for everyone that isn't you, right? So there's a question of Google as the host of your data versus everybody else who might be trying to steal it. Today already, we encrypt all data in transit and at rest. So the second that your data hits our servers, we obfuscate it, we encrypt it, we move it to where it's going to be stored, and we store it in encrypted format. We have the keys to decrypt it, but if somebody were to intercept it in the middle, they would get nothing but gibberish, right? So that level of encryption already exists. Now there's a lot of people that say, for compliance purposes or whatever, I need to hide my data from everybody. Google, I don't want you to know anything about it either. I don't want you to be able to decrypt it. I want to be the only one to decrypt it. And for that, there's a service that's called bringing your own keys, bringing your own, essentially, encryption keys. We are close to supporting that for pretty much all of our storage formats. At the end of the day, there is some question as to how you're consuming the storage, right? So if you're using a storage provider, like you're using a Dropbox or something like that, I mean, just as an example, right? Dropbox doesn't run on Google Cloud. Dropbox, the application, could encrypt the data before they put it on our servers. But again, they would have the keys to decrypt it, right? So the only model in which this really works is if you, on your application, before you transit the data to us, before you move it to us, you encrypt it using whatever encryption model you want, and you send it to us in encrypted format. We will encrypt it again, so it'll be double encrypted now. But that is, and in reality, that's the way that we store a lot of our data. When people ask, like, why doesn't Google store all of its data with user keys? Like, why can't I go in Gmail and put in a key, hide all my data, right? Well, the answer is that then you can't search it. Like, if you're searching for an email, or you want to see it, we can't do that anymore, because we can't, all of our search services are like one big program that manages all searching of all emails. We make sure that different people's emails are hidden from each other, but we wouldn't actually be able to look for a word in an email if the data was obfuscated, right? So there's a trade-off between the services we can provide on it and how obfuscated it is from us. And that's why in a lot of cases, even though the data is put to rest, we need the ability to decrypt it so we can do stuff with it, like searching it, things like that. But to be clear, in your situation, there would be no reason why you couldn't bring your own key and store it. And as a matter of fact, even though we don't support bringing your own keys, we have a customer called Workiva Web Filings. They do all of the SEC filings for all the Fortune 500. Google uses them, a lot of people use them. This is like the most sensitive data in the world, right? I mean, it's a company's financial performance data before they file on the street, right? And not only is it the most sensitive data in the world, but it's also owned and managed by the most risk-averse people in the entire world. Has anybody here ever met an SEC filings officer for a Fortune 500 company?
Would anyone admit that?
I don't know if they would admit it, but the reality is, like, you don't know who these people are unless they screw up. Like, if something doesn't get filed on time, and the company gets a massive fine, then, or they report the wrong number and they get a massive fine, those people get in trouble. They're the most risk-averse people in the world. And so, when they built their solution on Google, they encrypt the data before they were sent it to us, and we encrypt it again, right? But in that way, they're certain that no one can read it. And that can be done.
That would require us re-downloading it to decrypt it ourselves locally on our machines as opposed to some kind of platform where we could...
Well, it depends on how much you trust it, right? Like fundamentally, if you take that code that decrypts the data and you put it somewhere on one of our servers, depending on how I mean, my answer to you is, yeah, that's honestly relatively safe. You're probably more at risk of having a hacker come and take it from you than us looking at it. But it depends on how paranoid you are. Right? There are some models which no, and I don't mean that as an attack. I mean, like, it depends on how sensitive the data is.
Just a real quick follow-up. If somebody were to say, for example, my just Google account in general were to become compromised. Therefore, everything that I have stored on the on my Google Cloud is therefore compromised. Everything on Google Drive is compromised because they've gained access to my overall Google account. It'd be interesting to have features where I can encrypt and decrypt data within your storage platform. So that way, even though they might have my password and be able to, compromise my Google account, they still can't view the content of what I'm storing on Google Drive.
Totally. So we can take this offline. The reality is that there's a variety of different ways of dealing with this, but the answer to your question is that's already possible now.
Okay.
Yeah.
Max, back here.
Oh, hey,
Thank you for joining us.
Hi.
I want to leave sort of the world of high tech and get to a very pragmatic issue, and that is that I'd be interested in your personal methodology around being part of Google, a hyper-innovative company, producing innovation daily, hourly, minute by minute. How do you go about sort of scaling that in your own head? How do you architect that so you're aware of it and then begin to plug and play as necessary in this vast array of innovation?
Hide and hope they don't figure out that they hired somebody who's so unworthy of being on the team. So let me make sure I restate your question so I understand it. So your question is how do we, Google, keep up to date on all the innovation that's happening? Is that the question?
As an outsider, just consuming innovation, and you're one entity, albeit a very, very large entity, and there is massive innovation happening, and as a well-led individual wanting to be on the top of this, how are you consuming that in a way where you're not overwhelmed by it, and yet you're facile with the information so that you can pull it and use it when necessary, when so much innovation is happening?
Man, that's a great question. Let me take a second to think about that. I mean, the short answer is it's overwhelming. There's just so much going on, and not just, within the four walls of Google is just one small part of the things being done. I think that a lot of reading, a lot of talking, a lot of attending conferences like this, a lot of time spent honestly focusing on getting out of the information overload. There's just so much stuff out there to read, picking the data sources, picking the content that you read very carefully, and then honestly just being a huge nerd, loving this stuff and reading all the time. Like that's actually, the passion for it really does make a difference. It's much harder to get exhausted when you really love it. Otherwise, it would just completely exhaust the hell out of you. But look, just being in this room, despite all the stuff that Google is working on, and despite how big Google is and how well known the brand is, Google Cloud has an awareness problem. There's so much going on, and there's so much to know that it's, even for an entity like Google, it's hard to totally get the word out. We're already, for any other company, we would be a massive business, but Google is a $50, $60 billion business, and for that, that's the scale you got to be at to count. And frankly, it's hard. Everyone out there is doing great stuff. Honestly, Amazon is one of the most formidable competitors we could ever hope or not hope to have. They do incredible work, and it's actually really a pleasure to compete against them. Hopefully that answers your question, Joe.
Yeah, thank you.
Hi, Max. Fellow Cornell alum, 04, actually. I had a question coming from the custom AV side, the custom integration, home automation side of things.
Yeah.
I know you guys purchased Nest, Apple's coming out with HomeKit. Maybe you can talk a bit about how you see Google Cloud playing a part in that industry.
Yeah, absolutely. So I think the key, so we're moving to a world in which there's going to be sensors. I mean, everyone's already carrying around sensors, right? There's a sensor pack in this thing. It measures temperature, it measures, or actually not temperature, it's got an accelerometer, it's got a GPS, variety of, and it's got a light meter in it, it's got a variety of other things, right? It's got a microphone. And so I think kind of stepping back from a specific feature, a specific thing, I think that in the future, kind of really science fiction, like walking into a room and like the room knows that you're in it, and it knows what light levels you like, and it knows what music you like, and it knows exactly how long you're usually there for. Like, those things are not that far off. And the big problem is collecting all that data in real time, storing it, making sense of it, regurgitating it back in a way that can be consumed by a user or by a computer to do some other thing like adjust the light levels. And that's how I think the Google Cloud is really going to be involved. So we have enough compute power to be able to ingest in real time all this data coming in from all these sensors that are everywhere, right? Just like we do with Google Maps, where we take anonymous location data and we use that to determine how much traffic there is in a certain place, how long it takes to get from one place to the other. And so collecting all that data, storing it, analyzing it, and then delivering it as a service to Nest or whoever else is really the way that Google Cloud is going to be involved in. The other way that Google Cloud is involved in it is that it really, using the cloud de-risks getting into a business. You don't have to buy a data center, right? Like Snapchat, there's two guys in a room, had an idea, launched it, and now it's the biggest photo sharing service on the internet combined. With all the other ones combined, don't do as many photo shares as they do. They had 5 developers working on it. Adam, the founder, is the youngest billionaire in the history of the world, self-made billionaire, 23 years old, worth like on paper, but like $4 billion, right? But like being able to just get 2 guys in a room and spin up a machine, and then you're successful and you add another one, and you're successful and you add 10 more, then all of a sudden you're running a service that's the top 5 service on the internet. That's another, it might be an abstract way, but that's another way that the cloud really contributes, not just Google Cloud, but all of them.
Yeah, from a developer perspective, you showed a demo. One of the coolest things that I saw from your presentation was the execution of the query against the huge Wikipedia table. But that example was a simple query you had already in a node. But in order to use that computing power, for a real useful application, we'll need to write a lot of code. So my question is, besides the on-server processing power that you offer, where is Google right now in the developer tools? First, what kind of, because I guess there are some limitations, that you only host code, probably Java or some technology, not everything, probably not .NET, for instance. And first is that, what is the range of engines or language that you support right now? And second, what kind of tools do you offer right now, or Google has built, IDEs or Workbench, things to write that code to write there, to run there?
Yeah, of course. So we can take this offline because I'd be interested to give you more detail later. But we have an infrastructure as a service offering. So it's not just App Engine where you have to pick a runtime, like you have to pick Java, or you have to pick Python or Go or something like that. You can run anything you can run on Amazon on a VM, you can run Google on a VM. So you can, if you want to write code in Ruby, or you want to code in Haskell, or whatever you want to code in, you can run it on Google Cloud. So .NET, no problem. You can communicate with BigQuery through a REST API, so there's no need, you can issue queries that way, so you don't have to use the UI. And we can talk more about the specifics of BigQuery. In terms of developer tools, it's a tough market, right? Because it's pretty fragmented. Some people will use whatever's nicely integrated and whatever works, and other people have kind of philosophical associations to a particular tool chain. And that's another thing we can take offline. But we have, in terms of orchestration, we've got integrations with Chef and Puppet deployment. We've got, in terms of continuous CI tools, but we have an integration with GitHub, so you can push a repository directly. You can push a repository directly from GitHub. You can commit directly from the web IDE. I can walk you through all that stuff later, but there's some cool integrations we're working on. The real question for us is, what is the, either the single or the top 5 tool chains that people really love to use? Right? Jenkins, CloudBees, what is it? What is the full tool chain that people want to use that if we did the integration, people would use it? Right? It's hard to win in that market, and so we'd rather make it easy to use kind of whatever you want and put forth 1 or 2 opinionations about the tool. You might want to like GitHub, most people use GitHub, right? But that's kind of the way that we're looking at it right now. We can talk about this afterwards.
We're going to do 3 more questions. I've had 3 already picked out, but bear with us, maybe 4. And we have some closing statements, so hold up.
Hi, so my question is not as technical. It's more of, I'm familiar with the marketplace. So my question is more along the lines, is this domestic? Are you releasing this in the domestic market? Are you releasing this abroad in the Latin American market? And are you thinking of having regions where certain countries have rules where they like the data to be stored inside country, doesn't leave the premise, the borders? So is that something evolving, or are you just thinking of right now all the traffic going through the United States and dealing with those entities, whether they be enterprise or service providers, when you're approaching?
So the answer is it's evolving. I have responsibility for Latin America, so I can tell you very, very explicitly, like we are currently today doing business everywhere in the world. The real question is the data center footprint, right? The real question is the data center footprint. So at the moment, we don't have a data center that we're actively deployed in Latin America, which means that if you're writing code in Latin America, your code runs in the United States. That won't be the case forever. In the next 12 months, we'll be deploying a data center. If I was a betting man, I would say I don't know the answer, so I can't divulge any confidential information, but if I was a betting man, I'd say it's probably either going to be in Mexico or Brazil. Those would be my guesses. Probably Brazil. And we have the same situation all over the world. So we're currently deployed in Taiwan also with a variety of different data center deployments in the United States. But the expectation is that over the next 12 or 24 months, pretty much there'd be at least 3 or 4 presences in every major geography, right? So it's not a question of actually going out and building a data center, because Google has many, many. The question is, in order for us to open up a new zone, we need enough demand to make a meaningful investment, because we're talking about, like hundreds and hundreds and hundreds of racks, right? $100 million, $1 billion, and those are, so we're waiting to see the traction in the market and then making those investments very, very strategically. Make sense?
Perfect, right next to him over here. So, compute.
Show yourself. Oh.
Sorry, surprise. So, I think as you pointed out, compute is really a commodity at this point, right? I mean, you can prove your own point in that regard, which really pushes us into services in the cloud, right? Which is what the other gentleman's question was about, Roku, or what other tool sets that make life a lot easier to deploy onto. But one of the biggest challenges that I've been concerned about with the Google Cloud is that Google has in the past decided to shut down services sort of whenever they feel like it.
Yeah. Yeah, no, that's 100% accurate. So I assume the implicit question is, how do I know it's different this time? Is that Reader? Are you a Reader fan? Google Reader? Oh no. Well, I can give you the official answer, or I can give you the unofficial answer. I'll go unofficial. So remember when I said that Google thinks the guy with the most data is going to win? Well, over the next, I talk about this quite a bit, over the next 5 to 10 years, the expectation is that, because of these guys, almost all the compute presence that sits underneath desks around the world is going to end up in the cloud, right? Because this thing is running a sensor array, it's running a couple other things, and all the heavy lifting, all the data crunching, all that stuff is going somewhere else, okay? So if that's the case, then that means, oh well, I can't tell you how big Google is in terms of all the compute power in the world, but let's say it's a couple percent. Right? If 75% of all the compute power in the world is going to go to shared service locations, and Google is a small percentage, a single-digit percentage of all the compute power in the world, then that means that this game in the next 10 years is going to mint at least 10 new Googles. And that makes this an existential crisis, not just for Google, but for all the tech companies out there. And the smart ones are realizing that. They're saying, we need to get into this business, we need to get into this business big. But not, and so I wouldn't say, oh, well, Google Cloud is different, or trust me, or something like that. All I would say is that if Google doesn't succeed in this business, then Google's core competitive advantage of being the biggest network in the world, most infrastructure, a top 5 server manufacturer, those things go away. And that's not the official answer. This is Max Henderson speculation. So if anybody here is a secret member of the press that is going to say, head of Google America says Google's days are numbered, that is erase that from your memory. But that is honestly how I feel. If I look at the numbers, that tells me that they're serious. And if the internal investment, so another thing that I know is that Google has about 15% of its engineering staff dedicated to internal development. So like I said, we have a container system that we've been running internally. We built all of our own data centers, we built all our own hardware. About 12 months ago or so, we shut that entire division down. And we took all those people and put them in cloud. So there is no more internal development organization anymore. There is no people building data centers that aren't building data centers for cloud. There are no people writing code that aren't writing code for cloud. As a matter of fact, we deprecated Google's entire internal code base. So there's no new development against any features inside Google that aren't deployed on the same infrastructure that Google Cloud sells to external developers. So there's no such thing anymore. And for me, that's evidence that we're not turning back, right? Make your own determination, but as far as I'm concerned, between the existential crisis and the move to shut down all internal development at Google except for cloud infrastructure development, I think this is pretty good. Oh, I'll add a third thing to that. Last time I checked, cloud global IT spending was around $4 trillion, was the size of the market. So if you take the biggest, broadest approach to this, you say, oh, well, all right, AWS is maybe a $5 billion business, right? Something like that. So they've captured about a fraction of a percentage point of the market. So this cloud thing's kind of just getting started. And Google's a $60 billion business, so, okay, well, that could play. That could be a serious, even if you win only 1% of that market, you could double your market cap. Right? So I think in that way, with those 3 things, that makes this something that I think is going to stick around for a while. I'm obviously betting my career on it, so I'm very
Hey, Mr. Henderson. I wonder what is the advantage of the big query over the other data analyzing softwares, such as SAS, R, Stata, Python? Because if you install those softwares on a desktop, you can do them like the same way, right?
Yeah, so they're fundamentally different. BigQuery is the execution engine, and R and those services can do execution for you, but are ultimately more about the type of analyses you run. So to give you a concrete example, BigQuery has an R connector. So you can take a data set that's sitting in BigQuery, write R code against it, and issue that query on BigQuery. The major difference between BigQuery and like a machine that runs on your desktop is that BigQuery parallelizes the job. So like I was saying before, where you take 10 million numbers and you break them up over 1 million computers that each add up 10, and you reduce the execution time by a factor of 1 million, that's essentially what you just saw, right? Like when I clicked execute query, it took the entire Wikipedia code base or changelog and deployed it on 100,000 containers that each just read a small part of it. And they went, they summed everything up, and then they all reported back, added everything together, and returned a result. So that parallelization is the key differentiator, right? When you're running on a machine on your desk, you're only going to get as much power as is on that machine. And in cloud, you can parallelize in a way that you just can't on a physical computer.
Cool. We got one more right here. I can't get the mic to you. So just...
You mentioned about Heartbleed, and then you said you expect it to be a major IRS or something. I was wondering what your thoughts were about Sony Hack and if that you think that out of business.
I think, I mean, I try not to give you a cop-out answer like, oh, I think that was really important. You know? Oh yeah, sorry. The question was, I mentioned that I thought there was going to be a major security breach in the next, decade or so. What do I think about the Sony hack specifically? What do I think about the Sony hack? I think that it shows the sort of real. So first of all, I mean, it very clearly shows that there's a real threat, and that businesses can be masked. Even very large businesses that are generally well respected can be very disrupted by this kind of behavior. I think it also kind of almost creates a new frontier for warfare, right? Like, what happens when, again, this is like science fiction craziness, but like when China starts hacking, American companies because of a trade issue or something like that. I think it just like, we haven't operated at the level of sophistication in security, or at least not in the public sphere, to think about large companies that we all just implicitly trust being so completely torn to the ground, just being so totally defenseless. I think hopefully that's kind of an early wake-up call, and I think everybody has to honestly prepare for it. I think that we are far too trusting, and it's weird to say this because I think a lot of people are like people view Google as kind of one of the major harbingers of this, but I think we're all too trusting with our data, honestly. We really have to figure out. We live in a world where the internet is very serious these days, and what you put out there is very hard to take back. So I think both for individuals and for organizations, like kind of fundamentally rethinking what it means to store data, secure it, and what can happen, and seeing an actual very clear result of what can happen when you don't think through the implications. I don't think that there's a lot of organizations out there that have a hack response protocol, and I think the value's not in the plan, it's in the planning, right? But I think we're going to see a shift in that direction.
Cool. Well, we'd like to thank you for coming to talk. So like I said, before I get to the Titanic thing, we are not doing an official refresh in May. We're doing a city fintech meetup. We'll send out the details soon. Our next official meetup will be part of our startup series. So we have a series of events in the summer, which is how to ideation, so design thinking, lean startup, prototyping, minimal viable product, raising capital, and then of course launching and growth hacking techniques. So it's a series of events that go on over several months in the summer. We'll release that information to you guys shortly, but it's clearly focused on getting you guys to ideally come up with what it takes to launch a company and put it on Google Cloud. I see there's a lot of startups here locally. I see you guys are wearing some shirts, Click.com, and a few others, Brett Gage. So I would encourage you guys to go to Titanic, find these guys wearing these shirts, and just interact with them. These are local startups trying to do things and come to events like this to try to grow their company. So any kind of feedback or things like that, early beta testers, that's why we're all here. We're all trying to get their stuff going. And the last thing I'll say is Titanic. So we have a deal with them, $10 for wings and beer, which is an awesome deal. And I think Max will be there. So
do it.
Yeah. It's literally walking, so you just exit here, walk down the block, and you'll be Thank you for coming.